So is this? Okay, hopefully. Hello, everyone. I'm Shahriar. I'm a co-founder of Zero Savvy. It's a non-profit research organization in UK, and also I'm a research associate in Alan Turing Institute. I'm super excited to talk about this private proof of burn and like how using that you don't have to scream that you are going private on chain. It's a backbone of many new interesting protocols, privacy protocols, and let's head to the problem. So the idea is that privacy probably will never be as equal as invisibility. We want to make it as close to invisibility as possible. No matter like what type of privacy protocol that you are using, at some point you need to interact on-chain in a different way than just a normal transaction. Either you have to interact with a contract or there are some proofs involved. Anyway, you will trigger some sort of signal that might leak some information about you. And this can be very serious when, for example, you're a big firm, you want to go into the big auctions, or you're a big company, you want to handle your salaries of your employees privately. These things can be serious and can be captured by your business enemies or anything. So it's important like how can we make it as invisible as possible, just to look like a normal transaction. Okay, so the proof of burn, it's actually a very old concept. It existed from the early years in Bitcoin. And there were even very interesting blockchains built on it. It was involved in the consensus of the blockchain and everything. But it was academically formalized back in 2020. Definitely check that paper if you're a cryptographer, and that has very interesting properties proven about this. But things got very interesting, especially after August 2023, when some people proposed EIP 7503 and introduced the concept of zero-knowledge wormholes. And we'll see what is it about. The burning, what we know, what we are very familiar with is that, you just send your assets into address 000. Why we all know that this is a burning mechanism is that, of course, we are aware that it is super hard to find the secret key that can withdraw from this address. Everybody knows that. And I'm not going into the detail why it's secure, but yeah, it is like this. But it is proven that it's not only about having an obvious address. You can use any sort of secure commitment, think about it as just secure random function, that it's just other than the standard address derivation method in Ethereum. So this way, if you send the transfer to that type of address, you will know that it's impossible to withdraw from this address. And this can be done in any ways. You can say that, for example, yeah, I'm Shahriar, my vote is, for example, 2. And then you hash this string. And this is, of course, will result in an address that you can burn into. You know that your funds are gone. And okay, why would you do that? And this is where this EIP comes. And this is the very interesting part, is that you can prove that you have burned this token. And then you will keep this address private. So this way, this is the whole concept of private proof of burn. And very simplified version of it, this is not perfectly secure, but this is just simplified version of it, just saying that you prove that, I know a burn address that falls into this type of category of the address, and this address has positive balance in the latest state root of the blockchain. So basically, this is the whole concept of this, how this ZK works. And the very good thing about this type of proof is that it is very composable friendly, in terms of the cryptography. It is not proven in UC. If you're into these things, I'm really interested in to prove this in UC, so contact me if you're into those things. But you can combine this proof with interesting other proofs, like proof of innocence. So you can prove that, my funds are not part of a bad acting, or I'm not a hacker, and then you can burn your vote. and then you can participate, for example, in a voting. Or you can participate in a privacy pool that it's authentic. It is like there's no way that other bad actors could satisfy those kind of constraints. And even if you want to show that, you can actually show that, oh, my transactions are not burned transactions, or you can actually reveal it securely only to one person that how you have burned it. So if we revisit the problem is that with this kind of technique, you don't need to interact directly with a contract or a privacy protocol. You can burn your address, your assets, and this is just a normal-looking transfer with to just a normal-looking address. Everything looks random, and then the very good thing about this kind of protocol is your anonymity set. This is like the biggest anonymity set that you can achieve at the moment, and this is like every address on chain that hasn't have any outgoing transaction will be part of your anonymity set. This is a very big anonymity set, and this is the cool thing about this. So there are some current active research going on in this, using this kind of protocol. And of course, the very first one, the obvious one, is the EIP itself. So the EIP was like saying that, okay, you burn your ETH, you prove it, and then maybe you get something back. So for example, if it was integrated, for example, to the Ethereum itself, you could be able to remint Ethereum again. So EIP proposed something like this. This is a very interesting protocol itself. And the follow-up of that EIP is the guys behind that actually worked on building Vorm. And the idea is that you do the same thing, like you burn your ETH, you prove it, and then you get some token called burnt ETH. And then with this, they built a very decentralized tokenomics around it, that you participate in a mining pool with your burnt Ethereum. And then, yeah, it's a very active project now. It's going on. I'm not going into the details of the tokenomics behind it, but it's live on Sepolia. It's not on mainnet yet. And yeah, it got a lot of attention from the community. They have burnt more than like 200,000 Ethereums in Sepolia now. It's an interesting concept of tokenomics, and yeah, definitely go check their GitHub. And recently, like this is the best implementation possible for proof of burn, private proof of burn, and it's been recently audited by the Electisec. So this is a very promising implementation. Yeah, a lot of people have been contributing to this repository, and as I said, like you can see the burn addresses as type of commitments on chain. So it doesn't have to be always about the privacy coin. It can be anything. You can commit to votes. You can commit to your bids on auction. And this is another thing that we've been working on, and you can check the paper. It's formally proven to be secure. So yeah, this is another project that is going on. And thank you. Privacy is normal, and hopefully soon it will be normal too. Thank you.